Okay, recording is started. So, good morning, students. This is a class of geotechnical engineering. So, last class we have started second module of that particular subject, that is geotechnical engineering, and topic name is permeability of soil. Okay, and in the last class we have discussed about Darcy's law. Fine. So, we have discussed about what is permeability. So, what is permeability? It is a property of soil that's allow or that permit the passage of water or any fluid through the interconnecting voids within a soil mass. Okay, so we've discussed about that particular formula proposed by Darcy's, which is known as Darcy's law. And what is the formula? Q is equal to KIA, that is discharge or rate of discharge is equal to K into I into A, where K is your coefficient of permeability, I is your hydraulic gradient, and A, capital A, is your cross-sectional area perpendicular to the flow. So it is a Darcy's law of flow of water through soil. That is Q is equal to KIA. Okay. We also discussed in the last class about difference between CPS velocity and discharge velocity. Okay. So CPS velocity also can be termed as actual velocity since uh, water flow through the interconnecting voids only. So you should consider the area of voids only when you are uh, deriving when you are actually finding the velocity of flow. Okay, since we know the formula of discharge is what? Q is equal to V into A, isn't it? So from that formula you can find out the velocity. V is equal to Q by A, discharge per unit cross-sectional area. Okay, so if you consider the total area, means area of the voids plus area of the solids, then the velocity will be your discharge velocity or Darcian velocity proposed by Darcy's. Okay, and if you consider only the area of the voids, then the velocity will be your space velocity or actual velocity. Okay, so today we'll discuss two method or laboratory method for determination of coefficient of permeability. Okay, so we'll discuss how to determine a coefficient of permeability in laboratory. Okay, so first let me share my screen. Okay. Yeah, so it's a very also one of the small topic here. I just want to give an introduction to the particular two method, okay, which is used for determination of permeability, or you can say coefficient of permeability. That is that K term. K, okay. Since we know the Darcy's law is what? Let me take a pen. Okay. So we know Darcy's law Q is equal to K I A. Okay. So rate of discharge is equal to K into I into A, where A is your cross-sectional area perpendicular to the flow, and I is your hydraulic gradient, and K is your coefficient of permeability. So our main aim to find out this value, that is K, that is coefficient of permeability. Okay. So in laboratory, uh, we can find out the coefficient of permeability. Fine. So we have two methods. Here you can see the first method is known as constant head flow method. Okay, or constant head permeability test. Okay, and another one is your falling head permeability test. Fine. So I'll just give you some difference between these two and why we need two different your method to find out coefficient of permeability. Okay, so we have two different type of method to find out this permeability, because this constant head permeability or constant head flow test, it gives suitable result for only coarse grained soil. Okay, so I want to repeat again. So this particular test, this constant head permeability test, it is preferable, or it is done for coarse grained soil or cohesion less soil. Fine. And why it is called constant head? Because throughout the test, the head difference or water head difference will be remain constant. Okay, so in this particular test, that is a constant head test, what do we do? Here you can see this this slightly pink color you can see now. So this pink color section, it is the soil sample. Okay, this is a rectangular soil sample is fitted, okay, at a particular position in a laboratory, which having a length, suppose this is a length, I think this L should be from here to here. Okay, so this L will be the your length of the sample, and this particular soil having cross sectional area of capital A. Fine. And here you can see at the top of the sample, or top of the layer or soil layer, a overhead tank is fitted. Fine. And from the overhead tank, the water is continuously flowing through the soil in this direction, vertically downward, and the water will flow through this soil, and finally it will go out. Okay, and finally this particular water that coming out of the sample, it can be stored in a particular measuring tank that can be measured within a time how much water how much water is coming through this particular section or outlet at a particular time, with using a stopwatch or something like that. Within a minute, how much water is coming, so you can find out Q, that is discharge per unit time. Fine, meter cube per second is some like that, you can find out the value of Q. Okay, and this particular H will remain constant here throughout the test, because this particular head of water will not change, because it is a continuous flow water. Okay, so from an arrangement will be a water supply, water will be continuously flowing in this direction to the overhead tank, and it always, this head, it will be always remain constant here. Since it is remain constant, so the head difference between the overhead tank and bottom tank is here, also one tank will be there, so overhead tank and bottom tank will be remain constant. Okay, fine. Okay, so so this H remains same throughout the test, that's why it is known as constant head test. Okay, and this test is suitable for coarse grained soil only, and the formula for or to find the value of K, that is coefficient of permeability, it is that is discharge, that is Q, into L is your length of the sample, A is your cross sectional area. You cannot see the area A, it will be in a perpendicular direction. I will show you now. So it will, this is a 2D drawing, isn't it? So if you imagine, the soil will be like this, isn't it? Soil, if you say 3D diagram, so it will be like this. So this area, since water is flowing in this direction, so we have to take that cross sectional area, isn't it? So this area is represented this capital A, and H is what? H is your constant head. It will remain constant throughout the test, isn't it? So this is the formula to find out the value of K, QL by AH. Okay, and this is suitable for coarse grain soil. Okay, here you can see it is recommended for coarse grain soil only. Okay, next we'll come to the second one, that is falling head test. Now it is the now we can see the difference between the constant head test and falling head test. So in this particular falling head test, this head of water, or head of difference, or difference in head between the top water level and bottom water level, will not going to remain same throughout the test, since there is no continuous flow water from this top section. Okay, now if you see this drawing, okay, now first of all I want to mention here, this falling head test is recommended for fine grain soil, okay, or cohesive soil you can say. Okay, so remember this constant head test is recommended for coarse grain soil, and falling head test is recommended for fine grain soil. Okay, now here you can see the setup of the experiment is almost similar to that constant head test. This soil sample having length of capital L and cross-sectional area of capital A is fitted in this direction, in this manner, and one standpipe is fitted at the top of the sample. Standpipe, okay, fine. And at the bottom, one tank, bottom tank, you can say bottom tank is placed here to collect the water. Fine. Now some amount of water is some particular amount of water is poured from this particular inlet, okay, within this standpipe. Okay, suppose this much of water, initially the water is filled up to this level. Okay, now even, okay, fine. So water is filled in this direction, in this level, and you first, before starting the time or before starting the timer, you first, what you have to do, water uh, is continuously flowing in this standpipe still till that the water, the soil sample gets saturated, and finally what this water is come out and fill this water tank. Fine. Now you can see at the very beginning of the test, you can see now you have to stop the water. Now before starting the test or before starting the timer, you can see the initial head of the water level is this much, and initial the head of the water even in the bottom tank is this much. Okay, fine. Now here also one measuring tank will be there, it is not showing here. Measuring tank will be there, I will show you now like this. Suppose in this direction one measuring tank will be there. Now when you start at the t equal to 0, what will happen? The head of the water is say h1. Fine. Okay, so it is the initial head of water or head difference, the top and the bottom difference. Okay, now with some time, okay, with some time or with some passes of time, the water is try to come or go down within this tank and finally go into this tank. Okay, so what will happen? This head of the water will drop down to some this level, and then this level, and now that means what? This head is gradually decreasing from top to bottom since water is coming out and there is no continuous water or continuous flow water. Just like that, no, it is the different, it is a insimilarity between the falling head test and constant head test. ठीक है, यहाँ पे constant flow water will be not be there. Fine. So at different time interval you can measure the head of water. Okay, so like h1, h2, like that. Okay, fine. So from this, from the derivation, I don't want to mention here the derivation. Okay, so from the derivation of that particular this test, you can find out a general formula to find out your coefficient permeability, especially for or strictly for fine grained soil, or which is applicable in or which is done in falling head test. Okay, so what is the formula here? Finally I want to show here. See, k is equal to 2.3, okay, 2.3 log 10 h1 by h2 a t2 minus t1. Okay, now I just want to introduce what is this la. I want to share these things. So this k is what? K is your coefficient of permeability. Okay, here also you can write k. So k is equal to 2.3 l into a. Now l is what? L is your length of the sample. Here you can see this length of the sample. Okay, small a. Now small a is what? Small a is your cross sectional area of this standpipe. Okay, there is two terms, one small a, one capital A. Fine. Small a is the cross sectional area of this or diameter of cross sectional area of this standpipe. Okay, so L into a log h1 by h2, next divide by a into t2 minus t1. Okay, now capital A is what? Cross sectional area of the sample. Here you cannot see, it is a perpendicular direction. A is your cross sectional area of the sample, and h1 and h2 and t2 and t1 is what? h1 is a particular head in a time t1, h2 is a particular head in time t2. You can take any value at any time interval. Okay, you can, during the experiment you can measure different head at different time interval. So suppose this h1 is a head, initial head at initial time t equal to 0. Okay, now after suppose at after 5 minutes the head become h2. Then what will, how can you say this h2 is a particular head, okay, at a time 5, t is equal to 5 minutes, like that. So it will be t2. So it's up to depend on the problem or depend on the experiment. So you can uh, the value of h1 and h2 will vary, even t2 and t1 will be also be vary. Fine. So this is the formula for falling head test. The formula is very important. In some exam also the formula usually asks this formula and this one. Okay, especially this formula is usually asked since it is little bit difficult to understand or difficult to memorize. Okay, so you have to memorize this. Fine. K is equal to 2.3 la into log 10 h1 by h2 a t2 minus t1. Okay, I don't want to give a proper explanation right now. If you need, I can also give the derivation for that, but for now you don't need to understand these things. Okay, for now it's only you need to try to understand this formula. Okay, so yeah, so this is all about today class. I just want to mention here the two tests. That is first one is your constant permeability test, and second one is your falling and permeability test, which is used for determination of coefficient of permeability. Okay, constant test, it is used for coarse grain soil, and falling at test is used for fine grain soil. Clear? So this is all about today class. So yeah, I just want to stop my sharing now. Clear na? Any doubt till now? You can ask if you have any doubt. Else I'll just take my take your attendance then. Okay. So wait a second. Okay, respond to your call. Just a second. 9 today. Okay, respond to your call. Roll number 69, 51,
Present, sir.
52,
Present, sir.
53, 53, 54, 55, 56, 57.
Yes, sir.
Okay, 58, 59, 60, 61,
Present, sir.
62,
Present, sir.
63,
61 present, sir.
61 is given, 63,
63.
64, 65, 66,
Yes, sir. 66.
67,
Present, sir.
68, 69 or 69 to नहीं है 70,
Present, sir. 70.
71,
Present.
72,
Present, sir.
73, 74,
Present, sir. 74%.
Okay, 70 73 है क्या? 73 नहीं है ना? 74 दे दिया. 75
Present, sir. 75.
76
Present, sir.
77 78 79 80.
Present.
Okay. 81 82
Present, sir. 82.
83
Present, sir. 83.
84
Present, sir.
85 85 86
Present, sir. 86.
85 नहीं है. 85 87
Sir, 81. Present, sir.
84 दिया है. 87
81.
81 ठीक है. 87 88
Sir, 68.
ठीक है. 89 90
Present, sir. 90.
91 92
Present, sir.
93
Yes, sir.